Good morning. Welcome back. Happy Wednesday. Today we are on lesson number 22, graphing parabolas. You can see up here on the calendar, this is day 1 of graphing parabolas. I've highlighted the other day. It's going to be a little while before we get there, but we're going to spend 2 days on graphing these curvy things that we talk about today. We're kind of in the middle of our theme about quadratics and then brand new things called parabolas. Quest number 4. Still a little ways away on April 25th. Any questions on the calendar? Okay, so at the top of 179, with our summary, in this lesson we learn how to graph quadratic equations. Remember, quadratic again just means x squared is part of the equation. So number 0 here, recall the intercept method for graphing a line. Fill in the table in order to graph the line 2x minus 3y equals 12. So to find the intercepts, what we're going to do is individually set x and y equal to 0. So if we first set x equal to 0, I get 2 times 0 minus 3y equals 12. Right, just substituting 0 for the x. And so that 0 just disappears, so I get negative 3y equals 12. So y is negative 4. So I'll put a negative 4 right there. I can play the game by letting y equal 0. Go back to the original equation. How much is x? 6. Everybody's okay with that? Okay, so that means we have 2 points. First one is 0, negative 4, and the second one is 6, 0. Right? Really important that they have zeros in the coordinates. Okay, so we can plot those 2 points over here, 0, negative 4, 6, 0, grab a straight edge, and connect the dots. So that's the graph of that equation. Fair? Okay, and just something for us to remember, when we're looking for an x-intercept, which one of our 2 rows gave us the x-intercept? First or second? Right, x-intercept is this 6, 0 over here. So how do you find the x-intercept? You let y be 0. And how do you find the y-intercept? You let x equal 0. And so the key is that the way to find intercepts for lines is the way to find intercepts for anything. And today we're going to graph for the first time curvy things. They'll be called parabolas. But to find an x-intercept, you always let y equal 0. And to find a y-intercept, you always let x equal 0. So that part is consistent from what we've seen earlier. Okay, so in this lesson, we'll graph quadratic equations of the form y equals ax squared plus bx plus c. Remember, a, b, and c are just numbers. Jeff? Negative 6, 0. I'm not sure what you're asking. So you're asking me to connect the 3 dots? Which graph? No, 2x minus 3y equals 12 is a straight line, and it's this line that we've drawn here. And so we are going to graph U-shaped things today, but the equations will look very different from this. The equations are going to have x squareds in them, whereas this does not. Okay. Okay. As we said, we call the shape of the graph of a quadratic equation a parabola. Parabolas are kind of the next simplest thing we could graph. Like lines are the most simple, straightforward thing to graph. Not to take anything away from them, they're incredibly useful. There's a lot of stuff that we did with lines earlier in the semester. We're moving on to the next most complicated thing, which I think is what we're talking about today. So number 2 says below, are the graphs of three equations. Don't get distracted by the little subscripts here. That y1 and y2 and y3 is just our way to distinguish them. But really what you're supposed to think is y equals 4x squared minus 4, and y equals x squared minus 14x plus 60, and y equals the last guy. And so what we're going to do is find the coordinates of the y-intercept for each graph by using the equation. Now we just saw, how do we find the y-intercept of any graph? We let x equal 0. To find the y-intercept, you let x equal 0. So if you let x equal 0 in this first equation, we get 4 times 0 squared minus 4. What is that? That's negative 4. And in the second equation, if we let x equal 0, and there's two of them here, so we go 0 squared minus 14 times 0 plus 60. What is that? 60. And then in the last equation, let both x's equal 0. So we go negative 0 squared plus 10 times 0 minus 25 is negative 25. But remember, the y-intercept is always two numbers. It's two coordinates inside of parentheses. So all we have right here are single numbers. So for this negative 4, what's the y-intercept? Is it negative 4, 0, or is it 0, negative 4? Yeah, we gotta be, yeah, 0 was the x and negative 4 was the y. And for the next one, 0, 60. And the last one, 0, negative 25. Okay, and so we can plot these points and take a look at the graphs here. So the first one, 0, negative 4, looks like it might be that point right there, which I guess means that this blue curve is y1. So I'm just going to label that with a y1 right there. And in green, I've got 0, 60. 0, 60 is way up here. So it sure feels like that green guy is y2. And then the last one was 0, negative 25. I could buy that that might be that point right down there. So purple or whatever it is y3. Okay, so we've identified which one is which just by looking at y-intercepts. Questions so far? Okay, so we're going to kind of speed through some of the features of these curves so that we get a chance to actually draw one from scratch, which is quite a complex process. So some of the key features down here. Two of the graphs open upwards like a smile, and one graph opens downwards like a frown. And it turns out it's really easy to look at the equations and decide immediately whether it's going to open upwards or downwards. This blue guy opens upwards, this green guy opens upwards, and the purple opens down. Can anybody tell what is it that makes what a negative or positive where? Yeah, the y-intercept, yeah, those are both negative. Yeah, it's the A, it's the number touching the x squared. So I'm going to circle in red here. That is a positive 4. That is an invisible positive 1. That is a mostly invisible negative 1. If you are positive in front of the x squared, you open up. Negative in front of the x squared opens down. And so that's just written down here. Whether you have a happy parabola or a sad parabola is completely determined by the value of A. If A is positive, the parabola opens up. A little mnemonic here. Remember, positive people are happy. So if A is positive, you have a happy parabola. If A is less than 0 or negative, the parabola opens down. Remember, negative people are sad. Good? Okay. Part B says, how many x-intercepts does each parabola have? So the blue one, how many x-intercepts does it have? How many? 2, right? One there, one there. How many x-intercepts does the green have? None. It never touches the x-axis, which is kind of different from lines, right? If you just draw a random line, it's going to have an x-intercept, yeah? But some of these curves don't have x-intercepts, and that's okay. And how about purple? How many x-intercepts? 1. Turns out these are all the possibilities. Every single parabola you draw is either going to have 0, 1, or 2 x-intercepts. And I think that's written down in part B. To find the x-intercept, which we'll get practice with today, well, what did we do with the line to find an x-intercept? Yeah, we'll make y equal to 0, right? And so we'll do the same thing here. We're going to change the y's in these original equations to zeros. So we'll do that on the next page. Okay, taking a look at the two happy ones, the blue and green, they both have a lowest point, right? And the purple one has a highest point. Again, this is different from lines. Does a line have a lowest point? Does it have a highest point? No, it goes forever, right? But parabolas have an extreme point. And so I'll label them in red here, that guy, and that guy, and that guy. And those points right there are called the vertex. Plural is vertices, but every parabola has just a single vertex. And so we're going to need to be able to find that vertex. So let's take a look at the blue parabola. The x-intercepts look to me like they're at -1 and 1, yeah? And the vertex is halfway in between, yes? And so halfway in between -1 and 1 is how much? 0, right? And so what are we doing to -1 and 1 to calculate the halfway number? Add and divide by 2, right? We're finding the average of two numbers to get the thing right in the middle. So you add -1 and 1 and you get 0, divided by 2, it's still 0. That tells me that the vertex of this blue parabola is someplace where x equals 0. But x equals 0 could be here, but it could also have been way down here or way down here. So to find the y value, if you know that x is 0, well, hey, that's easy. We've got the book right here. If you know that x is 0, you just plug it in and find your y value. It happens we've already done it, but usually you won't have already done it. So to find the x value of that vertex, we average the two x-intercepts. And then to find the y value, you plug whatever x value you just got into the original equation. We'll see concrete examples on the next page. I think this is a good time to go there. Let's give it a shot. So all the stuff that we just did on that first page was looking at parabolas whose graphs were already given to us and then trying to figure stuff out about them. Much tougher is to take a blank piece of graph paper and the equation, some quadratic equation, and draw the parabola. So this is an involved process. Let's give it a shot. First of all, up or down? Is this happy or sad? This is a sad downwards parabola because the a is negative, and so that's written out right here. A is equal to -1, which is less than 0, so this parabola opens downward. Okay, moving on to the y-intercept. How do we find y-intercept? We let all the x's equal 0. And so if you let the x's equal 0, this guy becomes a 0. This guy also becomes a 0. What's the y value? -3. So that means that the y-intercept is 0, -3. Don't forget, it's always got two numbers, two coordinates. I'm going to ask you for both on quizzes and tests. So let's go ahead and plot that point right now, 0, -3. That's down here. Okay, so far so good. Next, part C is finding the x-intercepts. How do we find x-intercepts? We let y equal 0. So if I change the y to a 0, we get 0 equals negative x squared plus 4x minus 3, which is written out right down here. And solving that equation is something that we spent a lot of time on last class, right? Didn't we solve equations that look just like that? And it's already in standard form because we put the 0 right there on the one side, right? Wouldn't that be the first step, would be to get the 0 on one side? So we're lucky in that it's already in standard form, but that's where the luck runs out because we got to solve a quadratic equation, and that's generally a hard process. So we're going to do the 2x2 box. Let's just refresh our memories. I filled in part of it already. Negative x squared is in the top left. Negative 3 is in the bottom right. I've multiplied them already. This 3x squared is the product of that diagonal. What's the sum supposed to be? 4x is that term in the middle there. So what we're after is two things whose product is 3x squared and whose sum is 4x. Fortunately, there's not many things whose product is 3x squared. What is it? Yeah, 3x and 1x. Don't forget to list the x's along. That's one of the answers. There's actually another answer. What's the other answer that will get you a 3x squared? Seems like that's the only answer, but there's another one. Negative 3 and negative 1. That's it, right? Got to make sure you're comfortable playing around with the signs. Everything is not always positive. Okay, do we have a winner for one of these pairs? Does the sum equal 4x? Yeah, that top one, x and 3x. So we're going to put the x and the 3x in the two blanks. It doesn't matter the order, but let's all copy this order just so we're all staring at the same box. Okay, and then we're going to go to the first row and we're going to pull out the greatest common factor. What goes into both? X is good. Any other possible answers? Would everybody say X? Yeah, X is fine. Some people would say negative X. They would see a negative X squared and say, oh, I can pull negative X out, but totally good to put X. Yeah. Yeah. You're right. It doesn't matter. It just flat doesn't matter. The answers, yeah, it's going to go somewhere. For us, it's going to go up above, right? So then up above, x times negative x gives the negative x squared. How about this top right? Green x times something to be the purple x here. Positive 1. Bottom left, blank times this negative x is supposed to be positive 3x. That's a negative 3. And then check the bottom right. Yeah, that seems to work. So that means that our equation here becomes 0 equals two things in parentheses. So negative x plus 1 and x minus 3. You could swap the order there, that's fine. Okay, and so we want our two answers, our two values of x. Again, I've discouraged folks from just memorizing a little shortcut, but let's point to the, all right, so let's actually do it the right way, and then we'll show why the shortcut is not worth memorizing. So we've got two things multiplied to get 0, so one of them must be 0. So either negative x plus 1 is 0, or x minus 3 is 0. For the first equation, you're welcome to subtract 1. Personally, I would rather add x. That's going to get us the answer in one shot. Add x to both sides. X is 1. And the second equation, add 3 to both sides, and x is 3. And the shortcut that I've discouraged folks from using, even if they had it in a past math class, is to say, oh, whenever you get to this stage, all you got to do is change the sign of that number, and that will be your answer. All right, so does that work in this one? If you change the sign of this number, -3 becomes +3, which is correct. If you change the sign here, -1, is that the right answer? Not. Not. It's a silly shortcut to memorize. It doesn't work. It works sometimes, but what good is it if it doesn't work all the time? Okay, so x equals 3, x equals 1. Again, I'm going to be looking for coordinates. And this is not the point 1, 3 or 3, 1. What are the coordinates of the first x-intercept? 1 and 0. 0 is the very first thing we did in this problem. We changed the y to 0. And the other one? 3, 0 is good. Let's plot both of those points. 1, 0 and 3, 0. Now, so far we have 3 points plotted. And we're looking for a parabola that hits all 3. Now, some of you might have some trouble visualizing a parabola that's going to hit those 3 points. And I will remind you that we've already figured out this parabola opens which way? It opens down. And so if you're trying to fit in, we're over here. If you're trying to fit an upwards parabola onto those 3 points, you're going to have some problems. But this is a downwards parabola, which might be enough for us to see, oh, it's going to be something like that. Okay? All right, but we still need a little more information, so let's keep going. We're looking next for the vertex, which is the highest point, which is someplace up here-ish. I don't know exactly where yet, right? But I do know that the location of the vertex is going to be halfway between the two x-intercepts. So the two x-intercepts are 1 and 3. What's halfway between? It's 2, which is easy enough with these numbers, but the numbers might be messier, so let's just make sure that that we're okay finding the average. So that's this calculation here. Of course it's 2. But just in case it's not obvious, 1 and 3, to find the average, you add them and divide by 2. So we get the x-coordinate of the vertex is 2. That's my little x of v. That v just stands for vertex, but it's just an x-coordinate. But I want a y-coordinate. And so to find the y-coordinate, we're going to take that x equals 2 and plug it all the way back into that original yellow equation, right? That's the equation that tells you the relationship between x and y. So we are very carefully going to plug x equals 2 into here. Y equals -2 squared plus 4 times 2 minus 3. Now it's really easy to go wrong here. Like it's just arithmetic, but if you're not careful about the order of operations, you might get a sign wrong, and then that's a train wreck. This first thing here, +4 or -4? +4. -4. See? It's really easy to get this wrong. So here's my recommendation. Anytime you are substituting into one of these equations, you put parentheses around the thing you just substituted. I'm putting parentheses around both of these 2's right here. Does that make it any clearer? Is it +4 or -4? It's negative, right? That negative, for people who thought it would be +4, you were seeing the number -2 and you were squaring it. But that was not the number -2, not at any point. Not with the parentheses, not without. So this is equal to -2 squared is 4, so that's a negative when all is said and done, plus 8 minus 3, the rest is easy. We get 1. So that means that the vertex, what was the x-coordinate that we found? 2. And we've just discovered the y is 1. So 2, 1 is the vertex. Go ahead and plot that point. Okay, so the parabola, we can really imagine it's clearly taking shape now. But there's kind of some asymmetry in the collection of points that we've got here, right? Like, isn't there a point that like has a partner that we just haven't plotted yet? Which point? What's that? Yeah. Oh, yes, it's the symmetric thing. So which point up here is missing its partner? Yeah, the y-intercept at -3, right? It's got a partner, we just haven't plotted it. So how about we just make it a part of our routine whenever we're graphing parabolas, that we're going to make sure everybody gets a partner, which means just the y-intercept is left out, and so that's the only one we need to fix. So just by looking at the picture, we can tell, right? What are the coordinates of the symmetric point for the y-intercept? 4, -3 sounds good to me. You guys buying that? If you're not sure, you draw this vertical line right through the vertex. We know that that vertex is the mirror. And you say, okay, well, how far do you have to go to get from the y-intercept to the mirror? How far did we have to go? 2, right? So if you had to go 2 there, then to get to the partner, you better go 2 again. So that's why it lands on 4, right? It's 2 to get to the mirror and then another 2 because it's a mirror image. And how about the y coordinate of that point? How much is the y of that point? -3. It's just the same as the y-intercept, right? So that one you just copy. So this symmetric point here is 4, -3. I'm not going to write down any formulas for how to get it. We're just going to look at the picture and we're going to do the obvious thing to calculate those numbers. But I'm going to need you to write the coordinates like 4, -3. Okay, and then finally you connect the 5 dots. So go ahead and draw your parabola. And some people are very critical about their ability or perceived inability to draw nice parabolas. So I'm not going to be nearly as critical as some of you are on yourselves. However, there are 2 things that you will for sure lose points on if you do. So I want to make sure that you don't do these 2 things. Number 1, that. Parabolas are not straight. Parabolas do not have corners. They are curvy and they are smooth. And it's not just 2 straight lines. So don't do that. And then the only other common mistake that I see is this. What's wrong with that? It doesn't go on forever. Parabola doesn't care the 5 points that you plotted, right? It goes forever. So we obviously can't draw the forever part, but we could at the very least extend the parabola to the edges of our graph paper, and that's what I'll expect you to do. Okay, drawing parabolas from scratch is one of the most involved processes of the semester. They take time. Any questions on this? Okay, so the activity is on the next page. It consists of exactly 4 problems, which is a lot less than most activities. But each of the problems takes like 10 minutes, so take your time.